Hello friends, welcome back my YouTube channel MS Maths. In this video I will explain the concept of basics of group theory, that is what the general linear and spatial linear set. This is the part 6. In the previous videos that we have seen what are the basic concepts of group theory, and one by one I am explaining the basic concepts of group theory. You can follow my YouTube channel MS Maths and follow the playlist of group theory basics. You will get the concept of all the basics of group theory. This is helpful for all the examination like IIT JAM, CUET, NBHM, TIFR, CSIR-NET, GATE and okay, etc. And my name is Manoj Solanki. Please subscribe the channel so that you will get the notification of the newest video of the higher education and higher mathematics especially. So first of all, I'll start with the general linear set. Okay, in the series of this like defining the set, this is my 6th part. Okay, previously that we have seen what is Zn group. Okay, not Zn group, Zn set. What is what is Zn set, then after dihedral set, that we have also seen. Okay, and in this video we'll see what is your general linear group and then spatial linear group. Then I will explain what is your S3 or what is your Sn set. That is what all about the property related to the group theory, and that we will also see in the concept of groups. But here we are defining these sets. These are the basic set. Should have idea about all of these sets. Okay, so the set of n cross n invertible matrix. Okay, this is nothing but the set of n cross n. Whatever n cross n means, that it should be a square matrix. Okay, it should be a square matrix. And what? Invertible matrix. What is the meaning of invertible matrix? A matrix whose inverse exists. It means that A inverse exists for the matrix. So this is basically a collection of all those elements, like they are basically the matrices, the collection of all those matrices whose inverse exist. Let's say simply from here I can simply say the determinant of A is not equals to 0, because of that whatever the inverse of matrix, that is nothing but the adjoint of matrix A divided by the determinant of A, and the condition is that determinant should not equals to 0. So it means I can consider all those matrices in this set that who have the determinant is non-zero, or we can say what we can also define this is nothing but my non-singular matrix. Non-singular matrix, it means the collection of all non-singular matrices. I can define this set like this. The notation of this set is this G, L, N, and this is whatever the field here. Now what is field? That I have explained, that I will explain to you. Field is a ring. Field is a commutative ring. Okay, we can say commutative ring with unit and without unity, that we can also see like commutative ring, CRT. Okay, it is nothing but a field. So field is nothing but a tuple, so in which it is what? A set which is making what? Abelian group here. This is what your abelian group, that I will explain in the group theory. Okay, this is a set from which we are taking the elements. Okay, this is a collection of all those points from which we are taking the elements. So the real number is a field. So I'll write the example here. So field is what? Real number is a field. Q is also field. Okay, C is also field. Here Z is not field, but ZP is field, where P is my prime number. So this is my field. So I'll use these whatever the field here will define this set over this field. It means whenever we will have a matrix, then the entries of matrix are belonging from any of the field. Let's say from real number, from rational, irrational, sorry, from the complex number and ZP. Okay, now the definition of this set also we can define like this: a matrix which is n cross n. It means a square matrix whose determinant is not 0 and the entries are from field. That is what it may be: real number, rational number, complex number, or whatever you can say. That is your ZP means a field. Field, that is what the field with primes like Z5, Z3, Z2, Z. Okay, then we can also consider. So this is what your field, and this is the definition of general linear, and we are denoting it as like GLN of F, and we are also defining or denoting like this GN and F. These are two ways to denote this set. Next we have yes. wait, yeah, now we have two types of field. Let's say what are the field that I have explained to you. These what R, C and Q. Okay, R, C, Q, these are the field have cardinality infinite. It means if I will define the cardinality of these field, let's say what R, okay, the cardinality of R and the cardinality of C and the cardinality of Q, that is nothing but your infinite, means these are infinite field. Okay, so the cardinality of field is infinite. So F is infinite field. Let's say this, okay, it may be real number Q or C, whatever. Now F is equals to R. Let's say we'll take F is equals to R. It means whatever my entries from entries of the matrix, that will be from the real number. It means what are the definition here, that is what A n cross n, the determinant is non-zero and A I J are belonging from this, and the cardinality of this set is 0. Now sorry, infinite. How the cardinality is infinite, that you can relate here. If I will take, okay, how many number of matrices, how many number of matrices are existing in this we can say in this set, or in this whole world, that is what whose determinant is non-zero. We can make infinite number of matrix with the entries of real number whose determinant is non-zero. That's why the cardinality of this set is non-zero. Now if I will take n is equals to 1, so what is the meaning of n is equals to 1? So I'll just define the definition z, like z ln 1 over r. So this is nothing but A is equals to Aij of 1 cross 1. It means all those 1 cross 1 matrix whose determinant is non-zero and my entries are from real number. So you can make any of the matrix whose determinant is non-zero from the real number. Yes, whatever, you can take any of the non-zero constant, that will be a matrix, 1 cross 1 matrix whose determinant is 0, whose determinant is non-zero. Okay, and the order of this matrix, so general linear of 1, that is what the infinite, what the order, or you can say the cardinality of this set, how many elements will be in this set, that will be infinite number of elements. If it is greater than n and equals to 2, that you can define like this, general linear of 2 over r. It means whatever it is. So let's say it is my Aij, that is what 2 cross 2. A is equals to, okay, a matrix Aij which is 3 cross 3, that I can take here, and in which also the determinant is non-zero, and where my I and J are belonging from real number, and also the cardinality for this kind of set also. It means from here, because of that, this R is, the cardinality of this R is infinite. So the cardinality of this set is again going to be whatever, if it is 2, 3, it will be infinite here. This is what the definition and the formation, you can say, with the infinite field here, that we can see here. Okay, now if I will take okay, if I will take here finite field, let's say z of p, okay, that I have explained one more concept with you. Let's say any of the finite, not infinite, any of the finite field, let's say fq is nothing but zp, where p is my prime number. Now f is equals to, let's say my f is equals to zp here, then it is defined by general linear of zp, from where change is here only, the field, that is what my zp. Now here in this case, the order, or we can say the cardinality of this z is going to be this, whatever. So just see here. So the definition is z general linear n over field f. So whatever you will have the field, that is what my zp, so it will be zp. So here it is p and n. So what is the cardinality of this set is going to be simply, what is this, p power n minus p power n minus 1 into p power n minus p power n minus 2 up to what, p power n minus p power n minus n, that is nothing but p power n minus p power 0. It means p power n minus 1. This is what the cardinality of this set, that we will take the example and we'll see here. Okay, now here the construction of z general linear 2 with z2. It means what, my n is equals to 2 and the field is nothing but, the field is here, that is what, okay, let's say f, okay, the field is going to be z2. It means my p is equals to 2. So can I identify the cardinality of this set? Yeah, I'll identify and I can show you, but before that I'll show you like which kind of elements will contain this set. Okay, which kind of element will be in this set, that I will show you. So see here, this is what, and this will show you the order of matrix, means 2 cross 2. This is what 2 cross 2, and from where A, B, C, D are from Z2. Now do you know Z2, how to find Z2, or what are the element in Z2? That is what, 0 and 1. It means all the elements or all the matrix whose elements are from 0 and 1 but determinant should not equals to 0, that will be like that, that type of element will be in this set, or this set will contain that type of element. So can I make? Yes. So I'll just write here, so general linear of 2 with the Z2. Now how, what can be the shape of the matrix, or what can be the elements here? So I will take this one, 1 0 0 1. This is what, with the 0 1 entry is here, and it means determinant is non-zero here. Next, 1 1 0 1, determinant is also non-zero. So from here, yes, so from here, if it is 1 1 1 1, if I will take this entry, then 1 minus 1, determinant is 0, I can't take this. Then I will take what, I will take this 1 0 1 again here. Now see here, the determinant is minus 1, but one thing is that I want to tell you, if you will take 1, and that will be equivalent to 1 mod of 2. It means if you will take negative, that will be equivalent to 1. So its determinant is minus 1. And okay, one thing is that no need to, okay, we'll use this property, but here it is what, it is non-zero. Yes, it is non-zero. Clear? So this kind of element can be there. If I'll make one more here, so let's say 0 1 1 1, so its determinant is also non-zero. Okay, so if I'll start with this, then next, if I will take element like this 0 1 0 1, that is what, the again the element of this matrix, means determinant is non-zero. If I will take any matrix like this, let's say 1 1, okay, that we have 0 1, that we have already taken. So now from here, let's say these are the elements, and I don't know how many elements are in this set, so I'm just predicting. So it will be better that I will find the number of elements. So from here, what is p is equals to 2 and n is equals to 2 here. So the cardinality of this set is going to be what? So p power means 2 power 2 minus 2 power n minus 1, that is what, 1 here. Then it is what, 2 power 2 minus 2 power 2, 2 power 2 minus 2, that is what, 1. So it is nothing but 4 minus 1 second, it will be 1, 4 minus 2, and it is what, 4 minus 1. It means it is your 2 into 3, it means 6 elements will be there. Here is it 6, 1 2 3 4 5, one more element will be there. So we can find that element. How? Just see this. Yes, it is non-zero. We'll take this order. We have taken this order. So if it is 2, it is 3, then 6 elements will be there. Okay. So can we take any of the entry like this? 1 0 1 1. This is again here. Okay. If I will take let's say 3 and 2, one more entry will be there. Okay, because of that the cardinality is 4 minus 1. Okay, and 4 here 4 minus 2, here 4 minus 1. So can we make any of the entry like this, in which have the entry is non-zero? That is what, will have 1 1 0. Okay, it should be in the order, I think, like this, 1 1 0, and then 0 will be there, 1 1 like this. If 0 is here only, so this is like this, 1 1 1. I think this is one of the type also, that we can proceed with this, and we can identify how many elements are there, so that it will be better for us to find the number of or to find the elements of the matrix. Okay, so this is what the construction of Z2. Now it is what is the cardinality of ZL, general linear of 3 with 2. It means what, how many elements in this set of, or we can take how many matrices of 3 cross 3 whose entries are 0 and 1 only, and whose determinant is non-zero. This is what the definition. So first of all, here 2 is, p is n, p is 2, and n is my 3. So it is what, 2 power 3 minus 2. Okay, so what are the formula? That is nothing but p power n minus p power n minus 1, p power n minus p power n minus 2, and goes up to 1. So it is what? 2 power 3 minus 2 power 1, 2 power 3 minus 2 power 0. That is what? The 8 minus 4, 8 minus 2, 8 minus 1. So it is nothing but what? 4 into 6 into 9. So if you will take 4 into 6 into 9, it means 24 into 9. So 156 will be the answer. If you will multiply this, then you will get 156 here. Then same next question. Now here, what is p? So your p is 7, and what is n? That is 3. It means 7 power 3 minus 7 power 2. And again it will be 7 power what? 7 power 3 minus 7 and 7 power 3 minus 1. This is nothing but what? 49, 324 minus 49, and it is what? 324 minus 7 and 324 minus 1. And then after, if you will calculate it, 324 minus 1, if you will calculate, you will get the answer. That is what? I think okay, I have calculated this one. I'm not wait. Okay, yeah, this is 250. Okay, 2016, I think the answer. Okay, for previous one, I think it is wait, it is 2 power 8, then it should be 4 into wait, the mistake here, 9 minus 1, that is what? The 7. Sorry, I have just added. This is what? 4 into 42. So it means this is the correct answer. This is not correct. Okay, so 168 is the correct answer, because if you multiply, then you will get 168. Here 8 minus 1 is 7. Sorry for that. So from here you will get this answer, and in this case again the same question arises, that it was the 168 that we have already solved. And okay, yeah, I think this is also we have solved. I think slides are copied here. So this is what that we have seen, that is what? The general linear group, general linear set, not group. We are discussing the set only. Okay, so what if I will, okay, in that case we have the condition that the matrix of the determinant of matrix should be 0 only. Now if I will say the determinant is 1, then that is what? The spatial linear group, means n cross n matrix over the field F whose determinant is 1 only. That is what the case. Now we'll denote it by using this SLN. Okay, and in this case the again, if you will define like this, it will look like SLN1 over R. The cardinality like this: A is equals to Aij 1 cross 1. Now here just see, whose determinant is 1 and Aij from real number, only one element will be there. How one element? Only 1 cross 1 will be the element whose 1 cross 1 will be, or whose entry is 1, that will be only one matrix whose determinant is 1, because if you will write any of the number here, that will be the determinant itself, then it can't be equals to 1. Okay, that is what the simple case here. So here it is the if n is equals to 1, then over R it should be the cardinality is 1. If you will take in n greater than of 2 and 3, then you can get infinite number of over R infinite number of matrices there. Okay, now if I'll tell, okay, this is what over the finite field, that is what your Z of P. Okay, and if you will define like this, then your entry should be from ZP only, and the order is nothing but whatever the order of general linear divided by P minus 1 only. So P power n minus P power n minus 1, P power n minus P power n minus 2 up to P power n minus 1 divided by P minus 1. Okay, so we'll take one example and we'll construct this. So first of all, just construct this. So first of all, I will find the number of elements. So how many number of elements are there? So P is equals to 2. Okay, n is equals to 2. So P power 2 minus 2 power 1. Okay, and then here it is P power 2 minus 2 power 0. It means it will be 1 here. So how many? Okay, divide by 2 minus 1 means p minus 1. So it is nothing but 8 minus 2. It is your 8 minus 1 divided by, sorry, not 8, 4, 4, 4, 4, 4. So it is what? 4 minus 2, 4 minus 1 divided by 1. It means number of elements are going to be what? Number of elements are going to be 2 into 3, that are 6 elements. Now you will say, what are the 6 elements? Just I'll define the element 1, 1, 0, 1. The determinant is 1. If I'll define 1, 1, 1, 0, the determinant is 1. If I'll define 1, 0, okay, let's say 1, 1, 0. Now here determinant is not 1. Determinant is minus 1. But I want to say you the property that I told you, minus 1 is equivalent to 1 in any of the prime number. If we'll say right here 2, we will get the 1 here. Okay, this have also the determinant 1. So if we'll take 0, 1, 1, 1, this is also determinant have 1. If you take like this also have determinant 1. So 3, 2. And we can take one more example. That is what the simple case. If I will take let's say 0, then 0 here, yes, 0 here, 0 here. So 4 possibilities are this. And if I will take any of the side like this, okay, I think these are the same entries will be here in the spatial linear. Okay, the same entries. Yes, the opposite diagonal that we can also take. Wait. Yes, so 0, wait, again, so 0, 1, 1, 0. This is also going to be the entry of this. So 3 plus 3, the 6 elements are there. Okay, they keep this property in your mind, so you will get not confused here. Next, so what is the order of this particular, or what is the cardinality of this set? It means 3 cross 3 matrix whose entries are from Z7 and whose determinant is 1. That you can easily find. That is what P is your going to be 7, N is 3, so 3 power, okay, so 7 power 3 minus 7 power 2. So 7 power 3 minus 7, 7 power 3 minus 1 divided by 7 minus 1. That is what your answer, that you can easily calculate from here, that I have calculated, I think, and I can show you the answer is going to be, if you will multiply, okay, I have not calculated it, you can calculate and you can solve, or you can get the answer. Maybe this one will be the answer for this particular question. So this is how we can find the determinant, and if the determinant of any of the matrix is equals to 0, then we will define, not equals to 0, then we will define this with the spatial linear set, and if determinant is equals to 1, then we'll define, sorry, this is general linear and this is your spatial linear set. So these are two properties of the sets, that and these are both the groups itself that we'll discuss in the next video. So thanks for watching my video. Keep watching MX Maths, and thank you. Bye bye. We'll meet you in the next video.